The Motor King case. In this program, we will review the Motor King case requirements and discuss all of the decision analysis techniques that are required. The first step in the Motor King case is pretty straightforward. We need to construct a payoff matrix. From the given information, we can determine the payoffs for the different production levels being considered. This would be the number of units, 100,000, 75,000, or 50,000. Given the demand estimates, given the probabilities of a strong economy, a moderate economy, and a weak economy, we can determine a lot. So all of the payoffs, you can see the 9 shaded cells. We're going to have a 3x3 payoff matrix to show those 9 different payoffs. And then the probabilities can be used to determine things like the expected monetary value, or EMV, as well as the expected value of perfect information. Finally, from both of those, we can determine the max value in dollars of that perfect information. But we also need to go beyond our payoff matrix and work with some decision trees. Here we can see the basic structure of a decision tree for the Motor King case, excluding the DSI information. So let's look at this decision tree structure. We could see first a square. So remember, the square is a decision node. So Motor King is first going to have to decide on the number of units in the production run. This takes us to the next step. So those 3 circles that we see, the decision of 100,000, 75,000, or 50,000 units, takes us to a chance node, because no matter what, the economy is going to be either strong, moderate, or weak. So we can calculate the EMV from our decision tree as well. This would be no different than what we could obtain from the payoff matrix. The only difference is that we could visualize this. So once again, if we begin with our decision node, we can go to either 100,000, 50,000, 75,000, or 50,000 units. If we go to either of those, there's a chance of a strong, moderate, or weak economy. So with our payoffs and with our probabilities, just from the given information, we could construct this basic tree exclusive of the DSI information. So now let's look at what we could do with the DSI information. We're also given in the Motor King case instructions a description of some sample data. And from that description of sample data, we can determine some probabilities that we need to create a decision tree reflective of the DSI information. The basic structure of that tree is shown. So first of all, we could see that the tree begins with a chance node. So what's the chance event? Well, we don't know if DSI is going to predict strong, moderate, or weak. But using our sample information that's given, we can determine those probabilities. The probability that DSI predicts strong, moderate, or weak. And this takes us to our decision nodes, the 3 squares. Motor King still needs to decide on the number of units. Okay, so if DSI predicts strong, Motor King can still has to decide 100,000, 75,000, or 50,000, which takes us to another set of chance nodes. Because even if DSI predicts strong and the Motor King Corporation decides on 100K, we next need to consider, well, what's actually going to happen? Just because DSI predicts strong and Motor King decides on 100K, the economy still could be, given those conditions, either strong, moderate, or weak. So once we obtain the probability of DSI predicting strong or moderate or weak, what we need is to calculate conditional probabilities. We can't simply use the given probabilities of strong, moderate, or weak. Okay, these are assumptions of Motor King. What we need is the probability of strong given or if or conditional upon DSI predicting strong. Okay, so the three main branches reflect DSI either predicting strong, predicting moderate, or predicting weak. Now, for each prediction, Motor King needs to decide 100, 75, or 50K. So if DSI predicts strong, what's the probability of strong? If DSI predicts strong, what's the probability of moderate? If DSI predicts strong, what's the probability of weak? So we can use those three conditional probabilities 3 times for the 100K, 75K, or the 50K production run. So we end up with 3 times 3, or 9 possible results to consider. So let's see what we can do with the description of sample information on the DSI predictions. One approach is to use cross-tabulation. The crosstab that I've set up shows that the actual state of the economy is the column variable. Our row variable, these are the DSI predictions. For example, 10 out of 15 times were given, DSI correctly predicted a strong economy. And we can see on the crosstab the column total of 15. And we can see in that column 10 predictions of a strong economy. The other 5 times the economy was strong were also given. DSI predicted moderate 3 times, and they predicted weak twice. So this simple crosstab can be created, and from this we can determine very easily the probability that DSI either predicts strong, moderate, or weak. And that's the first chance node on our decision tree with DSI. So those 3 probabilities about what DSI predicts, strong, moderate, or weak, those are important to get our decision tree started, because that first event it's a chance node, right? And we need to have the probability of each prediction. But we can see that it's really important that we understand, if we're using cross tabulation, which is the row variable and which is the column variable. So again, the way I've set this up, the row variable is the prediction of DSI. The column variable is the actual state of the economy. So what we need to complete our decision tree would be, the way I've set this up, the row conditional distribution. I need the probability that the economy is strong, moderate, or weak if DSI predicts strong. And that can help me use my 9 payoffs, just as I did on the basic decision tree, but that's all conditional upon DSI predicting strong. In the same way, if they predict moderate, I need the probability that the economy is actually strong, moderate, or weak. And then finally, if they predict weak, I need the probability that the economy is actually strong, moderate, or weak. With my 9 payoffs and these conditional probabilities, I can determine an expected monetary value for Motor King, and given then the probabilities that DSI predicts strong, moderate, or weak, I can work all the way back to get an EMV given the DSI information. So now that we've looked at the crosstab approach to obtaining some of the probabilities that we need regarding the DSI predictions, let's take another look back at this decision tree structure with the DSI information. So beginning with the circle on the far left, this is our first chance node. Coming off of that, there are 3 possibilities: predict strong, predict moderate, or predict weak. Then we see our squares, our decision nodes, because Motor King is going to decide 100K, 75K, or 50K. So we could see the 3 branches coming off of those 3 squares. But then, if, or conditional upon, DSI predicting strong, we have 3 times 3, or the 9 payoffs coming off of those 3 circles. And so that's where we're going to need the probability of strong, moderate, or weak if DSI predicts strong. In the middle, if DSI predicts moderate, for those 9 payoffs at the far right, we need those conditional probabilities 3 times 3, or 9 payoffs, if, or conditional upon, DSI predicting moderate. And then finally, our last step in adding our probabilities would be this main branch on the bottom. Okay, that is, if DSI predicts a weak economy, we still need those 3 conditional probabilities to weight properly our 9 payoffs so that we can determine the EMV given the DSI information. This concludes the program Motor King Case Decision Analysis.